Hello grade 9 students. Let us discuss our first lesson this school year, which is the illustration of quadratic equation. But before we proceed, let us review first the multiplication of polynomials, which is needed to our main lesson. Are you ready? Number 1. 4 times the quantity x plus 6. Here, we need to use the distributive property of multiplication. That is, 4 times x plus 4 times 6, simplifying it, that is 4x plus 24. Next, let's find out the product of the two binomials, 2x minus 1 and x plus 3. Do you remember the FOIL method? Yes, we need to use the FOIL method to find the product of the two binomials. In the FOIL method, F stands for the first terms, and that is 2x times x. O stands for the outer terms, and that is 2x times 3. I stands for the inner terms, and that is negative 1 times x. And L for the last terms, and that is negative 1 times 3. So that is 2x times x plus 2x times 3, negative 1 times x, negative 1 times 3. To simplify, that is 2x squared plus 6x minus x minus 3. Finally, we have 2x squared plus 5x minus 3. Third, let's find out the product of the quantity x plus 4 and the quantity x minus 4. Are you familiar with this kind of special product? Yes, it is a product of the sum and difference of the two binomials, wherein the first term and the second term are the same in both binomials. They only differ in the operation. To multiply this, just get the product of the first term followed by the product of the second term, and that is x squared minus 16. Last, let's find out the square of the binomial 3x plus 1. In squaring of the binomials, we need to identify the first term and the second term of the binomial, and that is 3x and 1 respectively. To square the binomial, we need to follow this process. Square the first term, that is quantity 3x squared plus twice the product of the first and the second term, and that is 2 times 3x times 1, plus the square of the second term, and that is 1 squared. To simplify, that is 9x squared plus 6x plus 1. Now, let us discuss our main lesson, which is the illustration of quadratic equation. Do you know what is quadratic equation? A quadratic equation in one variable is an equation of second degree. The name quadratic comes from the Latin word quadratus, meaning square, because the variable gets squared like x squared. It is written in the standard form ax squared plus bx plus c equals 0, where the coefficients of a, b, and c are any real numbers, and the value of a must not be equal to 0. Now, let us discuss the standard form of quadratic equation, which is ax squared plus bx plus c equals 0. Our a is the numerical coefficient of the quadratic term ax squared, in which the value must not be equal to 0. Our b is the numerical coefficient of the linear term bx, in which the value may or may not be equal to 0. Our c is the numerical coefficient of the constant term c, in which the value may or may not be equal to 0. The exponent 2 is the reason why the equation becomes quadratic. It is the highest exponent of the variable. Let us identify which of the following equations are quadratic and which are not. Example number 1. Is 3x squared minus 4x plus 1 equals 0 a quadratic equation? What do you think? Yes, this is a quadratic equation, and it is written in the standard form. In 3x squared minus 4x plus 1 equals 0, our a is equal to 3, our b is equal to negative 4, our c is equal to 1. Example number 2. Is y times the quantity 2y plus 3 equals 0 a quadratic equation? What's your answer? If your answer is yes, you're correct. This is a quadratic equation. However, it is not written in standard form. If you encounter this kind of equation, all you have to do is to transform it to standard form. So from y times the quantity 2y plus 3 equals 0, it will become y times 2y plus y times 3 equal to 0. Finally, we have 2y squared plus 3y equals 0, where our a is equal to 2, our b is equal to 3, and our c is equal to 0 since there is no constant term. Next is the quantity 2x plus 1 times the quantity 2x minus 1 equals 0 a quadratic equation? What's the answer? Yes, this is a quadratic equation. However, it is also not written in the standard form. So from the given equation, it will become 2x times 2x plus 1 times negative 1 equals 0. Finally, we have 4x squared minus 1 equals 0, where a is equal to 4, b is equal to 0 since there is no linear term, and c is equal to negative 1. Sample number 4. Is the quantity x plus 1 times the quantity x minus 3 equals x squared minus 4 a quadratic equation? The answer is no. This is not a quadratic equation. Let us discover why. From the given equation, quantity x plus 1 times the quantity x minus 3 equals x squared minus 4, it will become x times x plus x times negative 3 plus 1 times x plus 1 times negative 3 equals x squared minus 4. Next, x squared minus 3x plus x minus 3 minus x squared plus 4 equals 0. From our equation now, we can eliminate x squared and negative x squared. Finally, we have negative 2x plus 1 equals 0. Since the highest exponent of the variable now is 1, therefore, it is not a quadratic equation. Instead, it is a linear equation. Last example. Is 5x squared equals 0 a quadratic equation? The answer is yes, this is a quadratic equation. From 5x squared equals 0, our a is equal to 5. b is equal to 0 since there is no linear term. C is also equal to 0 since there is no constant term.